Welcome to the fifth part of SpringBoot tips series. In this video, we are going to learn about how to write integration tests using Testcontainers library. In the previous part, we have learned how to write unit test, slice test, and integration test. But before going to explore how to use test containers, let us understand what is the need of test containers in the first place. The modern applications talk to a lot of external services like databases and messaging systems and cache servers and third-party services as well. So while writing any integration test, you may have to talk to one of these services or multiple of these services as part of your testing scenario. So in order to set up all these services while running your test, that's a very tedious process. So earlier, the process was like there is a test environment where all the services are installed and configured. And while running the integration test, you talk to those services. But the problem with that kind of a setup is you can't run multiple builds at the same time. Let us say you have a build pipeline like Jenkins or GitHub Actions or whatever other build server you are using. You can't trigger parallel builds because it is unpredictable. Maybe you are expecting your database contain a couple of records, but due to multiple tests running parallelly, there could be more records than expected, and your test suite becomes very flaky. So you will end up running only one build at a time. So instead, what if whenever we are running a build, if we are able to spin up all these dependent services and then let your test talk to these services, and once the tests are run and these services are destroyed, right? So that would be a clean way of running your integration test without having to worry about parallel executions. This is exactly what test containers do. Test containers is a Java library for running test, which uses Docker under the hood. You can use this test containers library to spin up whatever the required services as Docker containers and let your tests talk to those containers and execute your tests. If you remember in our previous episode, we have written a slice test using add_data_jpa test annotation for testing our Spring Data JPA repository. But while using this add_data_jpa test, it automatically creates an in-memory database if we have in-memory database driver in our class path, and let our test talk to that database. But using a different database than what we are using in production is not a good practice. We should be talking to the same type of database that we are going to use in our production. Let's say in our production we are going to use Postgres, then ideally you should be using Postgres database for running your integration tests as well. So now let us take a look at how we can use test containers library and automatically spin up a Docker container of Postgres and talk to the Postgres database instead of S2 in-memory database. The first thing to do before using test containers library is to add test containers dependencies. If we go to start.spring.io and let's say we have Spring Web and Postgres driver and Spring Data JPA starters added. Now we can select test containers starter as well, and if we explore, there is a new property added under property section, test containers version. Let us copy that and add it to our form.xml, and there is a dependency management section where it is added test containers BOM bill of material. So let us copy that as well. Okay. So now if I take a look at this dependencies, one JUnit Jupyter library is added and test containers Postgresql library is added. Let us add these two as well. And also we want to use Postgresql. We don't want to use H2 database anymore. So let us copy Postgresql and replace this H2 database dependency with Postgresql and reload our project. So now we are good to start using test containers. If you take a look at this existing @data.jpa test annotation, you can see it is annotated with @autoconfigure test database. So what this annotation will do, if you have any in-memory database driver in your class path, it is going to automatically configure that database and use that database for running your tests. But we want to use a real database like Postgres. So the first thing to do is turn off that behavior. How we can do that? We can add this @configure test database and replace equals to none. So essentially, it is going to turn off that auto configuration of in-memory database. The next thing is we can use test containers library to spin up a Postgres container. Okay, let us create a static PostgreSQL container equals to new PostgreSQL container, and we need to specify what is the Docker image we want to use for spinning up Postgres container. I want to use Postgres 14-alpine. So this is the image I want to use for spinning up my Postgres database container. And we can use these JUnit 5 callback methods at before all and at after all. So these methods, they are going to run before running any of the tests once per the entire test class, and this after all gets executed once all the tests are done at the end of the test suite. So here we can use these callback methods to start this container and stop this container. However, we are spinning up this Postgres container, but how does our SpringBoot data JPA know we need to talk to this database, right? Ideally, we would be configuring these data source properties in our application properties, saying that spring.datasource.url equal to so and so, spring.datasource.username equal to so and so, like that, right? But Spring Boot provides a mechanism where we can override any of these parameter values dynamically. So we can use this dynamic property source annotation, and it should be a static void method override database properties. This can be any name, whatever you want. And it takes dynamic property registry as an argument. Here we can add, in a sense, we can add or override. So let us configure spring.datasource.url, and we can take this Postgres container, and using this method reference we can get the JDBC URL. And let us also configure username and password. And here it is get username and get password. Because when we are running this test, it is going to spin up a brand new Postgres container, and the values would be dynamic. The port binding would be dynamic. It is not going to be static, typical Postgres port like 5432. It is going to allocate a dynamic port number that is available. So we don't know ahead of time what is the port number will be. But we could simply call this get JDBC URL method, which will figure out on what port it is running and prepares this whole JDBC URL for us. And we can use these method references and then override these properties. Now, when we run this test, it is going to talk to the database pointing to these JDBC URLs using these credentials. Okay, we haven't specified what is the database name and what is the username and password. Ideally, we don't have to, but if required, we can specify them as well. So now let us run this test. And before running this test, make sure that you have started your Docker desktop I am using. So I have it running. So now I am running this test. So right now I can see test containers automatically pull the image if it is not already in my local, and then it is spinning up the container. Once the container is started, here you can see the logs saying that your Postgres 14 Alpine container is starting. Okay, and we can see in our application logs that it is using this JDBC PostgreSQL and this random port and ran the flyway migrations and finally executed our test. So now we are able to run our test talking to a same type of database that we are using in our production, not using a in-memory database. Okay. So now we have this test which is using Postgres container and running our test fine. However, if you notice, this is going to be a common pattern, like we will be having one static container definition here, and then we will be using these callbacks to start and stop this container. As this is a common pattern, the test containers team provide this JUnit 5 extension at test containers at the class level, and for the container definition we can use at container, so that we don't have to use these callback methods to start and stop the container. We can simply use at test containers at the class level, at container annotation on this container definition. So it is going to take care of automatically starting this container and then stopping the container after the tests are run. Okay, now if we run this, it should work exactly same as earlier. Yeah, it is working fine. So one thing to note is while running these tests, there are so much of logging from this library, Docker Java, which is being used internally by test containers. So if you go to test containers documentation, under system requirements, there is recommended logback configuration section where you can create this logback test.xml. Under src test resources, we can create logback-test.xml and copy this. So here we are limiting org.testcontainers package to info log level and com.github.dockerjava package to one log level. So now if we run, we should be seeing a little less logging, so that we can see only main important log statements only. Okay, now let us go back to test containers documentation and take a quick glance at what all the features it is providing. So here we can see we can use JUnit 4 or JUnit 5 or Spark also for running our tests, and there are a lot of features here. We'll come back to that section. And if you go back to this modules section, there are a lot of modules it is providing support for. Ideally, you should be able to use any Docker container in your tests. There is a generic container class which you can use to specify what Docker image you want to use to spin up a container. However, there are some common modules which are being heavily used in our applications like databases. So we use all these RDBMS and NoSQL type of databases very commonly. And also there are a lot of messaging systems like Kafka, RabbitMQ, and there are search engines like Solar or Elasticsearch, things like that, which are we use very commonly. So they have created dedicated modules for that, so that it is providing a little bit more convenience methods also. For example, if you go back to our test, so here we are using Postgresql container. So here we can even specify with username, with password, with database options. So here I can specify demo. Here I can specify with username admin and with password is secret. So I can directly specify these container specific options as well. Whereas we can use at container static, and instead of PostgreSQL container, I can use generic container. I can use the same Docker image as well. However, I won't be getting this with database, with username password. Those options I wouldn't be getting, because it is generic container doesn't know anything specific about what container you are using. So if you want to use any Docker image which is not having any dedicated module by test containers, you can use this generic container and spin up that container based on the image you want to use. Okay. One of the most common use case of using test containers is to spin up database containers. So the test containers team make it even much more simpler to use any of these database containers. If you go back to test containers documentation, under modules databases, there is JDBC support page. Here you can see there is much simpler way to spin up database Docker containers. If you specify, usually this is the format we use for configuring JDBC URL. JDBC colon MySQL colon localhost port number database name. But if you put TC colon after JDBC colon, it is an indication that SpringBoot understand that it needs to use test containers to spin up the respective Docker image. Let's take a look at these URL patterns. So for MySQL, and if you want to specify this version of Docker image, you can specify JDBC colon TC colon MySQL, and 5734 is the Docker image name. Okay, and you can specify this database. So in our case, we are using PostgreSQL, right? So let us copy this JDBC colon TC colon Postgres. And how do we specify that data source URI? We can use at test property source and specify properties. And right now, we just need one property, spring dot data source dot URL. Okay. So here I want to use PostgreSQL version 14-alpine. Okay. With that, you don't need at test containers annotation at the class level, and you don't even need to specify uh, this PostgreSQL container also. We don't need these callbacks as well, and of course we don't need this property configuration as well. So what we are doing, we are simply specifying spring.dataSource URL equals to, and using this test container specific URL format, database URL format. And if you want to use any specific version of Docker image, we can specify that here. Okay. So with this one, if we run, it will identify, okay, this is a test container specific URL, and it takes care of spinning up the respective Docker container and run the test. Very convenient, and kudos to both test containers and SpringBoot team to make it working like this. So now that our Spring Data JPA repository test is good, how about our existing controller integration test? So earlier it was working fine. Now let us run it and see what happens. So it is failing because it's saying failed to configure data source URL attribute and is not specified, and no embedded data source could be configured because we removed H2 database driver dependency from our form.xml as well. So for running this integration test, we need to specify a data source. One option is, again, we can use at test containers. Okay, so here we are able to configure this integration test to spin up Postgres container, and we have registered this dynamic JDBC URL and username password. Now let us run this. Yeah, now it is automatically spinning it up and then configuring these data source properties, and it is working fine. But right now we have only one integration test, and what if we want to write a lot more, and all of them require this data source? So it is going to be a lot of duplication. So one pattern that we can use, instead of configuring this again and again, what we can do, let us say I am going to create a class called Postgres Container Initializer. I'm creating a class, and I am implementing application context initializer, which takes configurable application context type parameter, and I need to implement this initialize method. So here I'm going to again define this static Postgresql container, and in a static block I'm going to start this container here, and within this I am going to use test property values dot of. So here these values would be spring dot data source dot URL equals Postgres container dot get JDBC URL, and similarly I'm going to configure username, and here it will be get username, and password would be get password, and I need to apply to this application context here. Again, to recap, I am creating a class called Postgres Container Initializer, and I am implementing this application context initializer, which takes configurable application context. And here I am creating a static Postgres container definition, and in static block I am starting this container. And because I am implementing this application context initializer, I need to implement this initialize method. And here I can use these test property values of, and then configure what are the properties you want to configure. Here I am overriding all this data source properties, URL, username, and password. And by this time, it already started. So I'm able to get this JDBC URL and username and password and apply to the current application context. Okay. Now we have created this. How are we going to use this one? So now if you go back to our product controller integration test, let us comment out these and also comment out this at test containers as well. So here I'm going to use this annotation of at context configuration, and I'm going to specify initializers equals to, and here Postgres container initializer class. Okay. So now I am not configuring within this test. I am pointing out to a initializer that I have. Now I have commented out this Postgres definition within this one. So now if I run, it should spin up the same Postgres container and run the test using that database. So it is working fine. So the advantage is even if you have so many integration tests, you can simply use this at context configuration and specify this. You don't have to duplicate this code again and again. Okay, let us go back to test containers documentation and explore some interesting modules. In addition to various SQL and NoSQL modules, there are a couple of very interesting modules that comes very handy while doing the integration testing. One of them is local stack module. So local stack is a AWS service mock service provider which you can use to run locally and then verify your AWS specific services instead of talking to the real services. So this test containers local stack module we can use, and then we should be able to integration test any of the AWS features like S3, SQS, etc. In addition to that, if you go back to this diagram, in addition to talking to Postgres, RabbitMQ, Redis kind of a services, at times we talk to external third-party APIs as well. So let's say we are consuming these services and we are performing our own business logic on top of it. So we can leverage this mock server module where we can spin up a mock server and then we can provide these mock responses for various API calls, and then we should be able to test our own business logic based on these stubbed responses. So these two comes very handy when you are working with AWS or third-party APIs as well. If we check in the features section, there are few interesting features that we would like to know. If you go to networking and communicating with containers, so whenever we are spinning up a container, there would be some ports that are running inside the container, and they are going to be mapped to a different random available port on the host. So we should be able to get what is the mapped port on the host. Let's say we are spinning up some Tomcat or something like that, and it is running on port 8080 within the container, and it is going to map to some randomly available port on the host. So we can use container.get mapped port to fetch that what is the mapped port on the host. And sometimes, let's say we want to run some commands inside the container. For example, if you are using local stack and you want to create a local stack container and you want to create couple of S3 buckets. So you might want to go inside this local stack container and execute AWS S3 make bucket, some commands like that. You will be able to do that using this container.exec in container. You can use AWS local and then create S3 or SQS queues, something like that. And also, at times, we want to wait based on different strategies. Suppose we want to wait for a particular port to available, or we want to wait for certain message inside the logs. So you can use different criteria for wait strategies. Also, you may want to copy some files from your host into inside the container. So you can leverage this file mapping and volume mapping option where you can mount either a file or a directory from your host file system into container. Also, a more convenient option is you can map files or directories from your class path inside the container. So this comes very handy if you want to share some class path resources as well. One of the concern while using test containers is if we have a large number of integration tests, it's going to spin up one or more containers for each test class. So that is going to take some time to download those images if they are not already downloaded, and also it's going to take some time to spin up those containers as well. One option is to use what is called Singleton containers. If you go to test containers documentation under test framework integration, there is a section called manual container lifecycle control. So here there is a section called Singleton containers. So what we can do, instead of spinning up the containers and assigning them for each test class, we can create a base class and then define what containers we want to use, and in a static block start those containers. And all of your integration tests can extend that base class and use the same container. So here the same container will be used by all of your integration tests. But you need to be careful about the data setup. So because the same container is being reused by all of your integration tests, you need to be very careful about the test data setup. You need to set the test data and then clean it up in a organized manner. While test containers make it very easy to implement integration tests using these disposable Docker containers, there are few challenges. Let's say in some of the financial sectors, developers doesn't have the permissions to download random images from internet, or developer machines are not powerful enough to spin up those many containers locally. So in such scenarios, there is a better alternative created by the very same team who is working on test containers. There is an organization, newly found organization called Atomic Jar, who created this Test Containers Cloud. Instead of downloading all those Docker images into your local laptop and then spinning up all those containers locally, Test Containers Cloud enables us to download those images into the powerful machines on the Test Containers Cloud and spinning up all those containers on the cloud itself, and we will be able to talk to those services from our local machines or from our build machines, so that even from a less powerful hardware, you will still be able to use test containers and get the benefit out of test containers based integration testing. Test Containers Cloud is still in the early access phase. If you get access to Test Containers Cloud, you will get a link where you can download the Test Containers Cloud desktop application. And once you install, you will be able to start the client application here, and we can see it started. So earlier, when you run the tests, you can see at the console, it is using operating system Docker desktop. It was using actually my Docker desktop installation on my local system to download the images and then spin up the containers, and then using those containers, it ran the tests. But now I have started the Test Containers Cloud app, and if I run the test now, it should use this Test Containers Cloud instead of this Docker desktop. If we see here, server version is Test Containers Cloud, operating system is Ubuntu. So now it is not using Docker on my local, it is using Testcontainers Cloud to run the integration tests. Once the Testcontainers Cloud application is running, you don't need any code change to talk to Testcontainers Cloud. You can simply rerun your tests and it should be able to talk to Testcontainers Cloud without any code change. So this makes really even from a less powerful developer machines, we can still run test containers based integration test very quickly. And let us even check if we quit Docker desktop and if I run this test, I am still able to run the integration test without any problem. Okay, so even I don't even need to have Docker up and running on my local machine when I use Testcontainers Cloud. As we have seen, test containers really makes it easy to write integration tests talking to real services than mocks. It's really a game changer. And also with Testcontainers Cloud, even from a local less powerful machines, we are able to spin up a lot of containers and then run our integration test very quickly. And the best part is test containers is not only available for Java. If you go to test containers GitHub repository, you can see there is test containers Java, test containers Go, and it seems some of the new language support is coming up. Test containers Scala, Node, and Python, Rust as well. So it's going to be a really wonderful library to use even if you are working in different languages. Looking at how test containers is making it easy to write integration tests using real services instead of mocks, I hope you do agree that test containers is a must-have tool in your tool belt. And I hope this video is helpful, and thanks for watching.